Axial piston pumps. In axial piston pumps, the pistons are parallel to the axis of rotation of the shaft, or slightly inclined at an angle of not more than 45 degrees. To pump fluid, the pistons in the pump must move forward while the drive shaft rotates. Converting the rotational motion of the input shaft into the translational motion of the pistons is possible due to the inclined position of the bent axis, or the swash plate on which they rest. In the first case, the device is called a bent axis pump. In the second case, it is a swash plate pump. Let's try to figure out how these pumps can pump fluid. First, let's check the pump design. Let's take an adjustable bent axis pump as an example. The pump housing has a distinctive curved shape, and its shaft is supported by bearings. The pistons are attached to the shaft with spherical bearings and placed into the inclined block mounted on the axis. In the pump shown, pistons are used to transmit the rotation from the drive shaft to the axis, while some other devices use cardan shafts as a drive unit. The block is supported by a valve plate that has a spherical surface. The plate has channels for supplying and discharging fluid to and from the pistons. The fluid leaves the valve plate and then enters the cover that has an inlet and outlet opening. The fluid from the tank is supplied to the inlet channel of the pump, from where it is sucked by the pistons. Consider the operating principle of one of the pistons. When moving through the suction area, the piston moves and increases the volume of the working chamber. Due to the increase in the volume of the chamber, the pressure in it drops and the fluid fills the chamber under atmospheric pressure. Having reached the extreme position, the piston begins to move in the opposite direction, thus reducing the volume of the working chamber, and the fluid is displaced into the pressure channel. Having reached the second extreme position, the piston begins to increase the volume of the chamber again. The suction begins, and the cycle repeats. Several pistons are installed in the pump housing. There are 7 in the example provided. While one piston performs suction, the other is pushing the fluid into the pressure line, and the third is in the extreme position. This design allows for a continuous supply of fluid with relatively low pulsations. The presented pump does not need any check valves, since its pistons always suck in one area and discharge in another. The design of swash plate pumps is different, but the principle of their operation is the same. The cylinder block of swash plate pumps is installed coaxially with the drive shaft, and the rotation is usually transmitted to the block using a key or spline connection. The pistons rest on a swash plate supported by special pushers that have a spherical surface. The cylinder block is installed on a valve plate connected to a rear cover, in which there are channels for connection with pressure and suction pipelines. When the block rotates, the pistons reciprocate. At the moment when the pistons move increasing the volume of the chamber, they are connected to the suction line. And when the pistons move in the opposite direction, thus reducing the volume of the working chamber, they are connected to the discharge channel. The pumping capacity of an axial piston pump is determined by the number and diameter of its pistons, the space between them in the block, as well as their stroke. The stroke of the pistons is determined by the angle of inclination of the bent axis, or the swash plate. The longer the stroke, the greater the pumping capacity. By changing the angle of inclination of the swash plate, you can influence the stroke, thus regulating the pumping capacity. We will try to explain pump regulation in one of our videos. Please subscribe to our channel so you don't miss the video.